Number 19, consider the following graphs of position versus time. Okay, this time we have a position on the vertical axis and then the time on the horizontal axis. So what we can do is focus on our position here. So for the first case, our study becomes x equals 15 meter. So we'll look at specifically at 15 meter in our potential versus position graph. And then here the x equals -5 meters. So we'll take a look at that. And finally, for our third graph, we have 10 through, we have an interval 10 through x equals 15 meter. Okay, so let's write down the relation between the position and also potential energy here. So potential energy is pretty much, well, let's generalize as energy. You know, the energy or work is basically force times distance. Okay? That distance is going to represent our position here, but also the force can be split into mass times acceleration, the Newton's second law, times d. When we have in our graph here for our 15 meter, when we have potential energy to be 0, as you see up there, that's like saying our net acceleration has to be 0 for case 1, because we have certain mass and we have a distance to be -15. There's no other choice but then our the acceleration has to be 0. So what does it tell us when the acceleration is 0? This tells us either the position, our object is not moving. Okay, case 1 can be split into two separate cases, so either not moving or it's moving at constant speed. Okay, so if you take a look at 1, he's not moving, right? Over time, he's not moving at all. So 1 is correct, because it either describes not moving or moving at constant speed. Now let's take a look at -5. When you go to -5, we don't have potential energy to be 0, right? However, it's describing it's not moving as time progresses. But we just found that the net work is not equal to 0. So it's not matching with our condition here. So case 2 is actually wrong, incorrect. And our case 3, so technically this should be moving. Okay, we have ma net times distance. As we see in our graph, we have a -5 joule, and our distance is -5, so we can replace that d, and mass has to be positive. Also, that means our net acceleration has to be positive. So that means we should be accelerating, but we're seeing the same case as the first one, so it's not moving at all. So that's why this is incorrect. Now the third case is between 0 to 15. If you take a look at 0 to 15 meter, you do notice that the potential energy is not increasing or decreasing. So that's same scenario as the case 1. Therefore, this is correct as well. So answer has to be 1 and 3.